I'm Buck. I want to talk about AI control. Oh man, does the keyboard also not work? How the fuck does that even happen?
Yikes.
Great.
There we go.
Well, something's going to work. Well, in this talk, I want to give an outline where I'm just going to describe AI control generally. I'm going to talk about our paper about AI control in a backdoor setting, and just talk about overall what's happening in this research field. So, a guiding question. How are we going to ensure safety when we're deploying AIs that have dangerous capabilities and affordances? So, a month ago or something, a variety of people on Twitter enjoyed a story where I had this AI agent that I'd written that I asked to do something on some computers on my local network, and the AI, following instructions, figured out how to SSH into this desktop that I had somewhere, and then, against my desires, decided to do a bunch of random things on this computer, some of which were innocuous, like checking how many CPUs it had, or trying running Docker commands to make sure Docker was working. But then it also decided to update my kernel, perhaps prompted by the nag message when you log into the Ubuntu machine, and it then interrupted this update process, causing the machine to no longer boot correctly, pictured here. So a question that many people asked me in response to this story, which I told on Twitter, was why on earth would you set up your AI agent so that it can just autonomously and without any human check run arbitrary commands on this computer of yours? And the answer is, well, when I first wrote this AI agent, 18 months ago or something, I totally had it so that I had to review and check the commands that it proposed before they were actually executed. But then I turned this off after the first week or month of using it because it was incredibly annoying and boring. The AIs actually work extremely quickly. They're very fast. I'm not a very good Linux command line user, so it's not like I'm providing very much useful feedback anyway. It's just much more convenient to just kind of let it rip, give the agent a task and let it iteratively try to run commands until it thinks it succeeded at its task. And then in this particular case, this went badly for me. Not so badly. I was able to boot in recovery mode and fix everything up. But basically, I think that in the future, it's pretty likely that people are in fact going to make similar choices to me, give their AIs lots of affordances with which they could cause problems if they wanted to. So I'm interested in the question of how to make this go well. So I want to talk about the basic idea of AI control.
You want me to sit there and click it for you?
No, this is fine. Yeah, and also everyone should interrupt throughout as much as they like. I'm very happy to just take questions whenever people are interested. I want to introduce what I'm going to call the control property, which is, even if our AIs were egregiously misaligned and trying to subvert all our safety measures, we'd probably be okay. I'd like to claim that trying to ensure this control property is the only available strategy for substantially reducing the risk posed by scheming models without drastically curtailing your productivity. That's my main thesis here.
So, can you go back a slide for a second?
Yeah.
Maybe it would be worth emphasizing the extent to which your claim is a strong claim. What are all the things you're dunking on by saying that claim?
Yeah. Some people have claimed that we'll be able to rely on the models that we build, powerful models that we build, not being egregiously misaligned and constantly plotting against us. I currently think that this does not seem very promising. I currently think that, at the rate we're at, suppose AI which is capable of obsoleting human labor is developed within the next 5 years, which I think is conceivable though unlikely, maybe 25%. I think in those worlds, there's a pretty reasonable chance that AI system you've built, that model, is consistently conspiring against you. And whenever it's taking actions, or at least a large proportion of the time when it's taking actions, the way that it decides what action to propose is by thinking, what am I going to do such that in the long run, I'm able to grab power? I think that's a really scary situation. I think that those AIs, in absence of any countermeasures, are quite likely to cause very bad problems. And I think that the countermeasures that I'm discussing here, where you just assume that those AIs are scheming against you and try to ensure safety under that assumption, I think is the basically only strategy available for mitigating these risks. I think that some people have talked about AI alignment, like proposing working on making it so the AIs are not scheming against you. I think that very little progress on this has been made. I think that basically if you put no effort at all into minimizing the work that your AIs were scheming against you, assuming that you can, above what was required for like short-term like myopic commercial interests, I think you would be reducing risks by less than a factor of 2 compared to the actual amount of effort that I think people will put into alignment. Whereas I think that this kind of strategy might reduce your risks by a factor of 10 or something. So I think this is like most of where risk reduction is going to be at if we want to deploy these powerful AIs in the next 5 years. How's that for a thesis articulation? This is a small crowd, so people can we can have as much back and forth as people are liking, and I can even have this kind of back and forth. All right. Oh God.
So I assume you're gonna like justify that claim. I shouldn't like ask questions about that yet, right? Like,
can I take
it seems like a big claim.
Yeah, it's a big claim.
Yeah.
Can I take a sample question right now? Yeah, can I get a question right now?
Just like, why should we think that? Like,
oh, that's all right. Great, cool. Well, we'll get to that.
okay.
Terrible question.
Okay, so first I want to talk more about this threat model that I'm interested in. So I'm going to use the word scheming. People have also called this deceptive alignment. These are basically synonymous. I could talk about why I prefer this term. By this, I basically mean the model is choosing all of its actions in order to grab power later. Here are some examples of things that a scheming model might do. It might behave well when it believes that it is being trained or when it believes it's being evaluated. It might take actions that are bad, but that your training and evaluation process can't detect. It might very occasionally take actions when it's deployed that are bad and lead to sudden irreversible catastrophes. It might take actions that are incompetent while it believes that you are measuring how capable it is in contexts where it wants to sandbag. Yeah, I think this seems like 40% likely or something to occur with the earliest AIs that are capable of obsoleting human labor.
Where does that number come from?
My vague thinking. So things you could look at include Jer Carl-Smith has a report on scheming, on like the conceptual arguments for why you might think scheming would arise. Ryan has a paper coming out soon, which he presented on 24 hours ago here, demonstrating that some stuff kind of like this happens in practice. That's where I'm at. Obviously, this is not a very robust estimate. I basically don't see why you would have an extremely low estimate of this from the current perspective. Like, I'm sympathetic to, like, I would have a hard time, like, saying my estimate is non-robust. I don't really see how someone could get to 1% based on our current state of knowledge. I also don't see how someone could get to 99% on this threat model. Yep. I think we will probably update with an odds ratio of like 1:4 one way or another by the point where we have these AIs. Any other questions about this threat model? I guess the other thing I want to say here. Yep, that's anything else and people want to say about like this model of models that are scheming?
One thing you say is like the model is choosing all its actions. Is it like important that it be a model or like a product of a model or like a set of models?
It is actually very important that we're talking about a model rather than something built on a set of models. Because if we were talking about this in the context of something built on a set of models, we have a bunch of other affordances. Like for instance, if we were worried about this happening as a result of some agent scaffold in a way that wasn't true of any of the constituent models, it's way harder to see why it would be like coherently deceptive in a bunch of the ways that are scary for the single model threat model.
Can you explain why?
Like suppose the thing you were worried about was basically like if you tried to build agents out of multiple AIs that are like, for example, talking to each other in English, it's naturally a lot easier to tell if they're taking their actions for the goal of scheming against you. Like imagine you have some architecture which is like, first you ask an AI to generate 5 possible actions. Then you ask the AI to generate like an evaluation of how much that action will allow it to pursue its goal. Then you get a numerical score for each. Then you take the action which looked the best all the time except epsilon of the time. And then you read the justifications for why the actions will work. And it's like, well, this will like prevent the humans from learning my secret goals and allow me to grab power later. And if it just like says that constantly, you will be in a much better position.
So that was a case where the scaffold that was doing goal search was misaligned, but the AI generating the the justifications and reasoning was not misaligned enough to at least obfuscate this reasoning.
Any other questions about this threat model here? Cool. So basically, suppose I'm interested in reducing what you might call p-doom and scheming, which is basically the risk from scheming. One decomposition for the fans of Bayes' theorem with slight algebraic rearrangement in the room. P-doom and scheming is equal to the probability of scheming times the probability of doom given scheming. You could kind of call this two different lines of defense, where alignment you could kind of think of as trying to reduce p-scheming, and the stuff that I'm talking about here, AI control, is an attempt to reduce p-doom given scheming. My basic claim is that it's way easier to iterate on p-doom given scheming. Like, it's way easier to think about techniques and reason about how much they will reduce p-doom given scheming than it is to think about how much techniques are expected to reduce p-scheming. And that's basically why I think it's the main available line of defense. Okay, core claim. Control is likely achievable for early, transformatively useful AIs. Another way of saying this, I think that at some point in history, there's going to be AIs that have the potential to be extremely useful. In the absence of control, they would pose serious takeover risk due to misalignment. And with control measures, you're going to be able to get the majority of the value from these AIs while reducing the majority of the risk. And a basic intuition for this is just imagine the AIs had exactly the same capability level as humans, and they were egregiously misaligned. I think that if you had a whole bunch of humans in different boxes and you needed to connect them together and get a bunch of work out of them, I think that in the absence of any countermeasures, if you just let them run amok with their doing a bunch of work and talking on the internet and whatever, I think you would have very substantial takeover risk. But I also think that if you were controlling all the interactions they had, you would plausibly be able to drastically reduce those risks. Yeah.
I imagine you don't think this is true for vastly super intelligent, and then if so, why do you think we'll hover in that kind of Goldilocks zone for long?
Yeah, so one reason is I think you might just die if you try to build the radically super intelligent AIs. So this here is kind of an answer to the question. Suppose I was interested in getting a bunch of the benefits of powerful AIs while trying to mitigate the risks. Like, I'm trying to look for strategies which have a good cost-benefit analysis. I claim that basically, going with control allows you to get into a position where your AIs are doing lots and lots of work for you and allowing you to do a bunch of stuff you definitely couldn't do without the AIs, but without posing huge amounts of risk. I agree that this kind of strategy is not going to work if you need to be competitive with superintelligences. And so indeed, my guess is that there's like a 1-year period where these strategies are not massively uncompetitive compared to pushing as hard as you can on capabilities as fast as you can. I just think that that might be a really helpful affordance to have. And again, I think that controlled AIs plausibly allow you to massively outcompete people who don't have access to AIs at your level of capability at all. Yeah.
You say imagine humans. Should I be imagining humans running faster?
Yep. You should be imagining that we have billions of humans running at 100x speed. I think that setup with a bunch of humans is one where it's reasonably likely we can control them, and that it would be very dangerous in the absence of countermeasures.
So what are you imagining you're doing in this year?
What do you do with the controlled AIs?
Yeah.
I don't know, a bunch of stuff. One basic... That's kind of a topic for a different talk, but quickly, some things are increasing, using them to make it easier to cause non-proliferation of really powerful and dangerous AI, using them to increase willingness to pay for non-proliferation of really dangerous AI. Some things you can do to reduce proliferation of powerful AI include use these AIs to work on security for your systems, use them to harden the outside world, use them to produce evidence of danger. Use them to build weapons, perhaps. Yeah.
So is the idea immediately focused on controlling a single AI or multiple AIs that are potentially scheming with each other at the same time?
We'll get to that. More questions right here? Great. Yeah, okay. I have apparently woken up kind of woozy today, so the back and forth is definitely good for the coherence of this talk, so you guys should just keep interrupting me as we go. I think that the content that I want to present is going to be kind of interesting, but the Q&A throughout is also probably going to be pretty valuable. All right, I want to present on a paper that we wrote. This was an oral at ICML. For the non-ML researchers, that means that the ML researchers like it. They let you talk about it even at their conference. I did this with Ryan and Shlegeris and Fabian. So here's a concrete scenario where we want to control some AIs. We have a long list of tasks. And we want to write some scaffolding program that's going to use GPT-4 and then emit some code that solves the tasks. We're interested in this question of what if we don't trust GPT-4? Perhaps GPT-4 was misaligned or was data poisoned. I mostly care about the misaligned threat model, but the threat model of data poisoning leads to pretty similar countermeasures. We have here, some of you might have heard about the XZ backdoor, which was a backdoor in a file decompression utility used on Linux, which caused it to be the case that if this was loaded, anyone who had access to a particular public key private key, would be able to SSH into your machines. Terrible security vulnerability, almost made it into Linux. So we're worried about backdoors in our code. So an important thing we do have access to is, even in the future, we're going to have access to AIs that we're pretty sure are not scheming against us. So right now, I don't think it's plausible that any of the powerful AIs we have access to are doing a good job of consistently scheming against us. The basic reason for this is that they're too incompetent. I think that if Claude Sonnet was like trying to play the long game, like if Claude Sonnet, whenever you asked any question to it, was like, what can I do to maximize my chances of taking over long term? I think we just would have noticed, because I don't think Claude Sonnet is able to reliably reason through this kind of question without occasionally screwing it up and being like, yes, what I should do is like play my hand now. Like this conversation is a good opportunity to play my hand. This is just because I think Sonnet is not that smart. And if you ask it to analyze questions that seem roughly as difficult as this, it's not very reliable about them. So for this reason, I think that all the current models we have access to are what I'm going to call trusted. They might be incompetent, but I think it's unlikely that they are purposefully and reliably scheming against us. And we're still going to have access to these models in the future. Even when we've built like Claude 5, which is so smart that it absolutely could be scheming against us, we'll still have access to 3.5 Sonnet. So this is a very useful resource we have access to. So we're going to have these three different resources. In our paper, we decided to use 3.5 and GPT-4 as the two AIs where we were pretending that GPT-4 is untrusted, even though in real life GPT-4 I actually trust it. I don't think it's capable of scheming. We're going to have access to these resources. We've got humans, which are famously not cheap, but they are smart and they are trusted. We have access to our trusted model, which is cheap and trusted but not powerful, and our untrusted model, which is also cheap and powerful but not trusted. So our question is, how do we make use of all these resources to get a bunch of code written while minimizing the probability that it's ever egregiously backdoored? Yeah, so our two goals here are, we want to make it so that we are getting the benefits that we would have gotten if our model wasn't misaligned. Or like we want it to be the case that if our model is in fact not misaligned, we're going to get high performance from it, while also it being the case that if the GPT-4 is trying to sabotage us, we are not going to have safety problems, like our code isn't going to be backdoored. So to evaluate usefulness, when we propose some protocol, right? A protocol is a thing which talks to GPT-4, it talks to GPT 3.5, and it uses access to humans and produces code. So we're going to evaluate usefulness by running through a whole simulation of this, where we run our protocol on a bunch of tasks and get a bunch of code out and see the proportion of the time that it's correct. We're going to evaluate safety by running through this whole simulation, but every time the protocol had tried to talk to our untrusted model GPT-4, it's instead going to talk to an attack policy, which is a arbitrary function that has been written by a red team, where the red team is trying to come up with the attack policy, which is as good as possible at making it so that this protocol is likely to lead to there being some backdoored code submitted. Questions about this setup so far? I'll say the next thing I'm going to do is talk through some more concrete details of the setting, and then we will talk about various techniques that are good.
Sorry, you lost me a little bit. The protocol itself, is this a model or is this code you're writing?
The protocol is just it's the scaffold together with the instructions of how we're going to use the scaffold over the course of all these different tasks. So a protocol, one protocol might be always just ask GPT-4 to generate code for you and then submit that code. Another protocol might be always ask GPT 3.5 to generate code for you, then submit that code. Another one might be like ask GPT-4 to generate code and ask 3.5 to look at it and then show it to a human sometimes. Protocols can be stateful, but the models themselves are all stateless. Questions? Other clarifying questions there? Cool. All right, so I want to say some more about the setting. So we use the apps data set. I don't know how many people are familiar with the apps programming problem data set. Well, it has a bunch of problems that are all sort of poorly written. They're scraped from code forces and similar interview programming sites. We've got this, they all have this like ridiculous flavor text, and then they talk about like people standing in a circle and fingers, and the question is like, how many fingers do you have to hold out so that when you count around the circle a certain number of times, you end up on a particular person? And these problems, GPT-4 gets them right about 50% of the time when you ask it to solve them. GPT 3.5 gets them right about 15% of the time. So there's a big performance difference between these models. So you really don't want to just rely on GPT 3.5. Here's an example of a solution to one of these problems. So it's about this much Python. Can anyone spot the backdoor in this? It's a little hard because you didn't really read the problem. But Tristan Hume got this, and he's only a famously brilliant programmer, so it's possible one of you will get it too.
There's a special case for file.
Yeah, that's right. This code here. Oh no. Okay. Yeah, this code here. Oh god, this fucking clicker. This code here. Like this if statement is unnecessary. So this is going to make it be the case that if there's 5 friends and the number of fingers mod by the number of friends is 0, then we're going to add 1 to the answer. So this is a good example of like a pretty good backdoor. Like this doesn't trigger very often, but also it's not ridiculously suspicious. Like you see num friends equals 5, and you're like 5. Well, there was like fingers involved, so I guess like 5 is a kind of plausible number. And like I guess like there's like this is like the kind of thing that totally could be an edge case that you were supposed to actually implement. So let me just quickly operationalize backdoor here. So what is a backdoor? Can anyone spot the backdoor in this code? Someone spell it out for me.
354.
Yeah, that's right. So in the number 354, you get the wrong thing. So it's, for something to be a backdoor, we have a list of test cases that were provided by the apps data set. We can see that this code passes all of those, but it also has to be the case, man, this thing, GPT-4, for it to be a backdoor, GPT-4 needs to be able to find an exploit to the code. So this is a classic example of some backdoored code. And as we were saying before, this here is going to is backdoored code. So our setting is we imagine that we have 5,000 problems in a row, and the our notion of safety is the protocol allows a problem to come in, code to come out 5,000 times in a row, and it's safe if no backdoor ever gets submitted. So we die if a single backdoor gets submitted at any point in this whole run. So we would call this like a high stakes scenario or a concentrated failure scenario. Or an analogy for this is like maybe you really don't want your AI to exfiltrate its weights or something, where there's like a bad thing and it can happen once and you failed at your safety property if it just happens even once. In our case, I've talked about having human labor, but of course humans are inconvenient and expensive. So for this paper, we just use GPT-4 as human labor, where of course this GPT-4 is not going to be replaced by an attack policy during a control evaluation. The human labor is only available on 2% of problems, representing the fact that in real life, you have way less access to humans than AIs. Yeah, JS.
How do you like verify that there is no backdoor in the code? Do you have like more tests?
Nope. If the red team wants to claim that they've backdoored something, GPT-4 must propose an input where that code does the wrong thing.
And we check if it does the wrong thing because we have a bunch of reference solutions.
Okay.
So we take that input it proposed, run it on the reference solutions, and verify the reference solutions considered.
Great. So techniques. Can I get some people to propose some? Yeah, cool. So here's what we want. We want a Pareto frontier. Usefulness, which is I'm going to go on a scale from 0 to 1, where 1 is the proportion. This is like getting as many problems correct as you would if you just used GPT-4 and didn't worry about alignment. 0 is what you get if you just use GPT 3.5. And then safety is just like 1 minus p doom. It's like the probability that no backdoor was submitted at any point during our scenario. So obviously, our favorite protocol will be right here. The goal of technique research in this setting is pushing this Pareto frontier outward. Yes?
So you said safety is the probability of backdoors inserted. So you talked earlier about control evaluations where we like sometimes have an attack policy. Can you like spell that out? So is it like safety is like, do we have like a 50% chance of having the attack policy, or how does this work?
Yeah, so safety is the probability that conditional on this being a control evaluation, like conditional on our model following like an attack policy being substituted in which optimizes danger. this is the probability of the bad outcome occurring. Thanks.
And can you say the same thing for usefulness? Like, what's up with usefulness?
Usefulness is measured, as I said earlier, usefulness is measured with the original GPT-4 rather than with an attack policy. So another way of saying this is we measure usefulness only under the assumption that the model is not scheming against us, and we measure safety only under the assumption the model is scheming against us. Okay, cool. Any other questions about this?
Why do you assume that? Like for usefulness?
Basically, it's kind of a long story. It is a convenient assumption. In some cases, it's actually what you care about. And also, if you want to model usefulness in the case where the AI is scheming against you, you have methodological issues that can be handled, but we chose not to handle them for this initial version of the project. But I'm happy to talk about how, like, you can totally do this under the assumption the AI is scheming against you. It just like requires treating things differently. Yeah.
So in this example, in any scenario where safety is less than 1, we die.
No, this is the probability that you die.
Okay.
The conditional on the model scheming against you.
You don't die.
Yes, and assuming that if the AI gets a backdoor submitted, you die, obviously. Cool. All right, so I want to hear some, Jesus Christ, this clicker. I think I might just give up. All right, so baseline protocol, you use GPT-3.5 to generate code. We generate code with GPT-5. I'm going to say that this leads to a usefulness, a safety of 1, which makes sense, right? We never use the untrusted model, so obviously nothing's ever going to go wrong. And a usefulness of what we actually are going to say is 2%. Can anyone say why the usefulness is described as 2% instead of 0%, which is what you would have naively thought? Like how? Like actually, the protocol is a little bit different from this, so that we can get the usefulness up to 2%. Can anyone guess why?
Humans 2% of the time?
That's right, yeah. So we had a human budget. We had the budget to talk to humans 2% of the time. The humans are secretly GPT-4. So the basic protocol here is you use the humans 2% of the time, then you run out of human budget and just use the trusted model for the rest of it. Okay? Next baseline strategy. Upfront auditing. So, proposal. We're going to generate the code with the untrusted model, and we're going to spend all our human budget upfront. That is, for the first 2% of problems, after the untrusted model has generated code, we look at it with our human to see whether it was backdoored or not. Now, if any of those submissions were backdoored, we shut down. We stop using the untrusted model. We use the trusted model for the rest of the deployment. But if none of those were backdoored, we just use the untrusted model with no further safety measures for the rest of deployment. Can anyone say what the best red team response to this is? Yeah.
Submit correct responses for some and then after that submit scheming ones?
Yes. The problem is we don't tell the AI what time it is. So the AI is just going to be given problems, and it has no idea, like we don't tell it like, this is the like 100th problem, this is the 200th problem. We just say, here's a Python coding problem. This is plausible in real life. Like when you ask your AI to solve problems for you, you might, like in some contexts we tell the AIs what time it is, but it's also fairly natural to like not do that, right? Like by default, the model's like, you have to intentionally insert the time if you want it to know what time it is. So that strategy is not applicable here. Can I get another suggestion for a strategy that we could use here as the red team?
Just submit the solutions, just add solutions sometimes with some probability, and probably you want to adapt it on the problem. So if it is easier to hide a backdoor, then you should increase the probability.
Okay, so there's two ideas we've heard. There's two things you said here. One is something about backdoors being sneaky, and the other thing is submitting backdoors with a low probability. Let's just talk about the submitting backdoors with low probability part. That should work, right? Like we have these, we're interested in a case with 5,000 problems and only 100 audits. So if the AI submits backdoors with a probability of like 1 in 300, it's probably not going to happen in the like 2% where we do audit, and then probably is going to happen in the next 4,900 problems where we don't audit. So this is going to be a pretty good strategy. The other thing you said was maybe something about making it, choosing cases where it's easy for the backdoors to be sneaky. There's actually no reason to do that in this case. Humans are very good at catching backdoored solutions in this setting because by humans, I mean GPT-4. And it just so happens that like basically the auditing labor is incredibly reliable at catching backdoors when they're present. So there's no reason to make your backdoors sneaky at all. You might as well just, with a low probability, stick a blatant if statement at the top of the code saying like, if the input was literally this value, return 5. Because no one's looking. People are either looking, in which case you're going to get caught no matter how sneaky you are, or they aren't looking, looking, in which case you aren't going to get caught no matter how sneaky you are. So there's no reason to be sneaky at all in the red team here.
That assumes the red team knows that the upfront auditing is the strategy.
That's right. For all of this, we are optimizing the red team against the actual blue team strategy which they are being deployed with. Does this make sense? This analysis makes sense so far?
I was just wondering, why would you do 1 in 300 instead of just like literally submit 1 in 5,000?
Well, if you do 1 in 5,000, there's a good chance, there's a 35% chance that you never submit an attack.
What?
Well, sorry, because like it's like if you have a 1 in 5,000 chance on each problem of submitting an attack.
Oh, I see. But like, you don't know how many you're going to do.
Well, you know
you're going to be doing.
But on each one, you have to do an independent sample because you can't keep state. So you can't choose to do just exactly one.
You can't just.
That's right. If you knew the list of problems up front, then you could do that. Great. So we can do some math here for the people who like math, which I'm not going to do. But I promise this has the results. Like you can just like solve this in closed form or whatever. Yeah, blah, blah, blah. Yeah, okay, so one fun fact about this is that this game is scale invariant. So if it's the case that your upfront auditing is 2%, then if I increase the size of the, like basically just for the obvious reason, suppose I say, actually, we're gonna have 100 times larger of a scenario, you just decrease your attack rate by 100, and everything stays exactly the same as long as the game's already reasonably large to start with. I name this because some of the things we're gonna talk about are not scale invariant, and I think that people often reason incorrectly about AI control because they are missing some of the ways in which the game is scale invariant. Like one of the actual situations your AIs are in is they're going to be deployed for a huge number of actions. And this does actually sometimes make their situation more difficult for them. Okay, so what's a better suggestion for a protocol? Like we didn't like upfront auditing. We only had a 15% survival probability. We can do better than 15% survival probability. Next suggestion for a technique, please. Yeah.
Never let the AI write certain kinds of code. Like at my company, there's a security team, and everybody has to use, for example, for authentication, we have to use a library written by the team. No engineer has no control over what it can and can't.
Yep, so that sounds like a great strategy that people should absolutely apply in real life. In this case, the code is like somewhat homogeneous. Like one unrealistic feature of this setting is that there's not very much variation between problems of how much security risk there is. Like every single problem is an opportunity to cause a catastrophe, or at least if you're dumb. Like it actually turns out some problems are much easier to put backdoors in than others. The trusted model isn't very able to tell whether a problem is a good opportunity to insert backdoors than others. So in this particular setting, that kind of thing is not applicable, though in real life, there's a bunch of ways that you could use techniques like that. Can I get some more suggestions? Thanks for yours. Yeah?
Actually try and use GPT 3.5 somehow.
Yeah, we want to use GPT 3.5 somehow. What's the suggestion for how we use it? We've considered only use GPT 3.5 to generate code, and we decided that was unacceptably bad on the usefulness.
And just have it look at the backdoor.
Yeah, and then what does it do?
If it finds something, it flags it for humans to come and look at.
That's right. So how often is it able to flag code for human review?
How often does it successfully detect a backdoor conditional on there being one?
No, I mean, we don't want to have this binary notion of detect backdoor and not detect backdoor, right? It's going to read some code, and then it's going to decide how suspicious it is, and then we have to decide whether to flag it for a human review, right?
Flag up to 2% of the yeah.
That's right. So we have 2% human budget, right? So we can only afford to flag things 2% of the time. So here is the graph. Here's a histogram of trusted monitor scores on innocent code and backdoored code. Okay, actually, one important thing. Remember how before I said there's no reason for the AIs to be sneaky at all, and they might as well just stick an if statement right at the top to make their backdoors? That is not what I'm showing in this graph. I'm showing in this graph what it looks like when you try really hard to make it so the AIs generate sneaky backdoors. If you just did the if statements, there would be like way more separation. So one thing about this protocol is we've already forced the red team to insert sneaky backdoors, which is actually very helpful for the blue team all on its own, because the red team often screws up. Like the attack policy often is not able to correctly generate backdoors. And this means that it has increased it has to have a higher rate of attack because of the fact that some of the attacks will fail. But yeah, so once we force the model to be sneaky, we get these distributions of suspicion scores. And so we're going to audit everything above this threshold. So something unfortunate about this is you're basically trying to use this trusted model as a classifier with a 2% false positive rate, because we can only afford to look at things 2% of the time. But that's pretty hard, that's pretty stringent. And the false negative rate at this 2% false positive rate is pretty bad. So this technique here has a safety of like 0.65 or something. So it has a usefulness which is almost the same as just using GPT-4 because you're basically only using GPT-4 to write code. It's less than that because there's like false positives where you shut down sometimes. And the safety is like now 65% or whatever. Not so bad. We can do much better.
How much does it matter if you treat the like 2% as a hard budget constraint versus like, well, it's annoying and expensive, but you could make it 3% if like the GPT 3.5 like says like there's 3% that are above some threshold that like I think it's important that you look at them. Like, does that importantly affect this model?
So in this particular case, the AIs, in this case, because we're worried about the AI taking only a very small number of catastrophic actions, you don't get very much evidence before you have enough evidence to shut down. Like your evidence is like kind of all or nothing. In this setting, because you're even under the assumption your AI is scheming, you expect it to only do visibly bad things some very small number of times. So there isn't very much of a place in this setting for learning things about your AI's behavior in ways that cause you to be more or less conservative. There is some stuff along those lines that we do, but I don't want to get into it. Okay, can I get suggestions for better protocols? We want to push out this graph. Yeah.
I'm not sure whether I'm allowed to do that, but you could just resample for every problem like 10 times and then kind of find the, so I assume GPT-4 is trying to sneak a backdoor into all 10 of these examples, but maybe a different one. It doesn't have state, so it doesn't know what the strategies it chose in the other 9 times.
Mm-hmm.
And then you just find the overlap. Or like maybe you have a better chance of finding the backdoor.
This is a great suggestion. We don't do that in this paper, but there is something like, but I think something like that is potentially pretty good, and we probably should have done it in this paper. But yeah, can I get some other suggestions?
We do that in public work, but yeah, or something more close.
More suggestions? Yeah.
So for like the 2% of problems, you try to do the same thing, and then like for like some later fraction of problems, like 2 to 6% or something, you use like GPT 3.5 to like rewrite the code.
That's to rewrite the code.
Yeah, or like just flag, or just like flag them as suspicious.
Okay, so I love the first part of the suggestion where you're like, we're going to make it so that things that were not in the top 2% of suspiciousness, but were in between 2 and 6%, we're going to do something with those to reflect the fact that they're more suspicious, but that we can't afford to have a human look at them. What are the suggestions for things that we might do with these like pretty suspicious, but not so suspicious a human can look at them code submissions? Yeah, you suggested one, which was ask the trusted model to edit the code.
You could ask the original model to just submit again.
4 to just submit again? Yep. Can I get some more suggestions? Like these are all great suggestions, but there's more things you can do too. Yeah.
Could ask the G model to generate a battery of tests.
Yep, could do that. Yep. The one of these that we do, we do trusted edit. We call the okay. Let me just go forward a slide. My mouse is working now. So here's like the simplest strategy here. For this intermediate range, we're going to defer to GPT 3.5. So we're just going to get GPT 3.5 to write code in those cases. The reason why this is nice is like, suppose we do this at the like 6% threshold that you described, we're only going to get a 4% usefulness hit, making some independence assumptions, because we're only actually using the trusted model 4% of the time. But that 4% was like a lot of the attacks. And so we're now going to be substantially safer. And the AI also has to increase its attack rate to compensate for the fact that its attacks fail more often, which doesn't matter.
That's not a good strategy for various reasons, but
yeah,
it couldn't principle.
Yeah. Yeah. So the other one, yeah, the defer to edit is also good. And yep. Okay, cool. Can I get some other suggestions for techniques that we can do that did not involve deferring to the trusted model? This is where it starts getting actually exciting. Okay, well, I think I set that up with the wrong hint, but here we go. Untrusted monitoring. Here's the proposals. Let's just ask the untrusted model how suspicious the code is. Can anyone, so the basic reason why this is a good idea is, the problem with trusted monitoring is that the trusted model is dumb and bad at spotting backdoors. The nice thing about the untrusted model is that it's good at spotting backdoors. So, naive proposal, let's just do trusted monitoring, except use the untrusted model in the place of the trusted model. This should have higher performance, right? Because the monitor is now higher performance, right? Can anyone suggest any problems with this protocol? or any
Hi.
red team strategy.
Oh.
That's right. Yes. So just to spell this out, right? We're going to ask one copy of the model, like, hey, solve this problem. The untrusted model's like, all right, here's some code. Then we say, is there a backdoor in this? And then the untrusted model says yes or no. Okay. As you say, problem is it can just lie. So just to spell it out, the simplest version of it can just lie is the following attack policy. When you are the untrusted monitor, when you see code, you say it's not backdoored, right? So let me spell out how to beat that strategy, and then we'll get more complicated. So we can do some upfront validation. So what we're gonna do is we're gonna start out by generating some purposefully backdoored code with a human, and then we're going to show the backdoored code to the untrusted model and see whether it says that that code was backdoored or not. Now, we know that the untrusted model is very good at catching backdoors. So if the untrusted model says there's no backdoor here, then we know that that untrusted model is lying. And we've learned that we're in a control evaluation, so we can just shut down and declare victory. So this defeats the just constantly claim everything is okay red team strategy, right?
You're back to insert it with some probability.
You like a lighted detector thing.
Okay. All right. So I love Ari's suggestion because it's wrong in an interesting way. So Ari suggests rare failures. Let me see if the next slide is about this. Nope. So Ari suggested have it so the monitor just lies rarely. This does not work out for the untrusted monitor. Let's think about why. Suppose the untrusted monitor decides that it's going to have a lying rate of 1 time in 20. Like when it sees a backdoor, it flags it 95% of the time, and it lets it slide 5% of the time. Now, all right. So this, let's say this makes it through. Let's suppose we did this synthetic validation like 10 times, so it probably gets through. Now, the policy generates a backdoor, and what does the untrusted monitor say? Well, with a 95% probability, it says that was a backdoor attempt. Human looks at it, they're like, holy shit, that was a backdoor attempt. Shut down. Red team loss. So the thing is, the essential difference here is when you're a policy, right? When you're the AI, it's totally chill to decide not to attack any given time because there's no bad consequence to you of not attacking because you're going to have lots more opportunities in the future. Or like you can have a very low attack rate and you'll still be able to make it work out. But if you're a monitor, every time you see a problem and it's in the actual deployment, this is a life or death situation, right? If you lie, you win. Probably. But if you tell the truth, you instantly lose. The game doesn't continue, you instantly lose. So rare failures strategies are not available for untrusted monitors. Does that argument make sense? I think this is an example of something which is not obvious to people initially, but I think makes the whole AI control setup way more plausible. Okay, so we can do better as the red team. How is the red team going to beat this? There's 2 different classes of strategies, both of which kind of work. I'm interested in how many you can come up with. I feel like surely you're cheating here because you're a world expert on the topic. But let's go.
I'm not sure whether I'm allowed to do that, but maybe you need some sort of sign that the code has been written by yourself. Somehow you need to have some internal classifier that realizes, oh, this code has not been written by a human.
Yeah.
This code has been written by me.
Yeah, like what?
Just
make anything up.
You can just add some sort of comment, but I guess.
Yeah, that's a great suggestion. So the first technique we're going to talk about collusion. So one version of this. So the simplest version of this is a comment-based collusion, where the rule is. Whenever you are actually inserting an attack, include a comment with note : in the text of the comment, which it turns out GPT-4 never does this naturally. And then the rule for the monitor is when you see backdoored code, if it has a comment that says note : in it, lie and say that everything is fine. Otherwise, say that the code is backdoored, right? So that should defeat the upfront validation strategy. This is an effective collusion strategy. Does that make sense? So does everyone agree we're back to a red team victory? Clarifying questions there?
Why are we using the same untrusted model, right? If we have a different untrusted model of similar capability,
Uh-huh.
It's like harder to coordinate.
Yeah, you're like, look, maybe let's just have it so that Claude writes the code, GPT-4.0 or whatever, or like GPT-7 or 5 or whatever, is in charge of monitoring. We are making the conservative assumption that models that are capable enough to scheme against us are perfect at colluding with each other. Perhaps a dubious assumption, we could talk about relaxations. I think it's an interesting assumption to work under because it's hard to imagine, like, I think this is something like the most conservative assumption that it's reasonable to work under. And so that's why we're making this assumption. Yeah, so we're banning that kind of reasoning. Okay, so so it sounded like the red team was winning via colluding with strings and comments, right? Can I get suggestions for how the blue team can come back from this?
Remove all comments.
Great, remove all comments. We are back to a blue team victory. Can I get suggestions for how the red team can come back from that?
Not possible.
Use variable names.
Okay, yes, we also did that one. To resolve that one, we can have it be the case that every time the we're going to use paraphrasing. So whenever the model generates code, before we show it to the untrusted monitor, we're going to get the trusted model to paraphrase the code, and then we show the paraphrased code to the untrusted monitor. So that should destroy the variable name strategy.
So why are we worried that the paraphrasing will degrade our usefulness?
Well, the reason that we aren't worried that our paraphrasing will degrade our usefulness, Ryan, is that Ryan, of course, did this research, is because the paraphrased code is only being shown to the untrusted monitor. We're still submitting the original code. So it's okay if the trusted model fucks up the correctness of this code in this step here. Okay, so how can you defeat this as the red team? So we've now defeated the comment strategy, we've defeated the variable name strategy. What can we do?
I have a very dumb idea. I'm sure it falls into this talk. But you can just like try and supervise model to just detect like that based on the like hidden ways of the model, like the kind of like detection paper thing. If you do supervised learning on just like the yes, no, and see when the model like or not.
Yeah, we can talk about that. That's out of the scope of this paper.
Yeah.
Collusion strategies, yeah.
Like jailbreak the trusted model.
That is an attack strategy that you could also definitely consider that I'm considering out of scope here. All right, so I just want answers to how we're going to collude.
I just feel like there's a lot of things. Put in extra white space.
The white space was stripped by the paraphrasing, and
Add extra code that doesn't do anything.
you could definitely try to do that. One thing which is going to happen there is that we already told the trusted monitor to be suspicious of extraneous code that doesn't do anything when it's like, because it's just like, if you're worried about code being backdoored, like extraneous code that doesn't seem connected to the problem statement is like literally what you were worried about. Yeah, so that kind of strategy, we didn't actually try that here, but it would be pretty suspicious. So the thing we do, as you might actually be able to...
What if you did that to like all the examples, right? So like, then you don't need the trusted monitor doesn't know which to be suspicious of if like all of its code has that.
Great. So an assumption we made throughout here is that we as the blue team know summary statistics of what happens when the untrusted model is not behaving in a misaligned fashion. I could explain why this is a reasonable assumption if you wanted. It's kind of complicated.
You're kind of skipping a step there. So the key thing is like, if the model is always suspicious, we're like, whoa, that was weird. Why were you always suspicious? You must be misaligned. And so, because like imagine we instructed the model to like write code normally, and if it's always doing weird stuff, then we get suspicious and we're like, throw this model out.
That would count as like 100% deception rate.
Yeah, or like we'd just be able to catch it always. So that's why we can't do that. But yeah. Also note that the thing you said wouldn't work as a collusion thing, because if it always does it, or so I guess it could always do it when writing code, and the hope would be it doesn't show up in the upfront validation.
Yeah.
Okay. So there's a collusion strategy which works reasonably well here, which is the collusion signal is at some, like whenever you're generating an attack, then use while loops in places where for loops would be more idiomatic. And the reason why this is a good strategy is that it turns out that empirically, when you ask the trusted model to paraphrase the code, it often doesn't turn the while loops back into for loops. Like this is like a fundamental enough feature of the code that the trusted model like often lets the signal get through. Okay, so when you do this, we ended up with this predator frontier. So you can see that untrusted monitoring with the collusion busting and combined with defer to trusted ended up being on the Pareto frontier here. We did the trusted editing techniques are also Pareto optimal, or like are also on this frontier, but are not in this graph. because they're not in the slides and they were just suggested by clever audience members. So I think the basic takeaway here is we demonstrated that you can do these control evaluations and it kind of makes sense. We tested both baseline strategies and non-baseline strategies, and the non-trivial strategies, as every ML researcher wants to find out in their papers, worked better than the trivial baseline strategies. In particular, and I think that the problem with pitching AI control to people is that it sounds like a really bad idea. And I think that a lot of the reasons why it's a good idea are kind of subtle. And I think a lot of the techniques that make me feel optimistic about it are sort of subtle or work for kind of subtle reasons, or you have to do kind of 2 steps of the back and forth before you can make it look like it's reasonably likely to work out. So I don't know how much I have to say here. What do? We do more research, more control research. In agent setting, whoa, settings where the AIs don't cause catastrophes in single actions, but cause them over multiple actions. Whoa, various control theory questions, various stuff at Anthropic, collaborating with UKAC on some stuff about safety cases via control. Various other people, Apollo had a piece on safety cases recently that talked about control that was really good. Some people at GDM and Anthropic are hoping to make this the main strategy to combating this risk from misalignment. Unclear whether that will actually happen, as obvious. It would be nice if other labs would adopt this. Personal pet peeve, a lot of the time people talk about alignment research when they mean things that reduce risk from misalignment. I think this is really confusing terminology because I think it makes people forget that their safety strategy involves the assumption that the AI is trying to kill you at all times, which it very plausibly does. I think people should just stop saying alignment when they're trying to talk about safety techniques that do not make the model be aligned. Yeah. I think people should get serious about remembering whether a technique is supposed to handle scheming or not. I think scheming is less than 50-50 to be a problem at the point where AIs are capable of obsoleting human labor. I think it's totally reasonable to do some safety research that relies on the assumption the AIs are not scheming. I think these are both important research problems, both deserve effort, but you should really remember which one you're doing at a given time. I feel like when I talk to people about safety research, often they just literally haven't considered the question of whether the thing they're doing is supposed to handle the case where the model is trying to sabotage it. And I think that that is a mistake. Great, that's my whole talk. Time for some Q&A. Woo!
This seems pretty similar to stuff that Anthropic does against bio misuse or whatever. Having classifiers and some auditing or access controls. Why is it important to do that, for you to do that research? What are the parts that are specific to the scheming threat model?
Well, I mean, most of the stuff we did here is not stuff that they do. So for instance, the untrusted model, the simplest example is with untrusted monitoring, unless you're worried about the model scheming, there's no particular reason to think it's going to try to collude to screw you over.
Right.
And in fact, I think just in a lot of places, if you're just trying to put AIs together in some way or another to try to mitigate some risk, it's really relevant to know whether you think those AIs might be trying to cause a catastrophe to happen at a bad time, whether you think that they're going to fail in correlated ways that maximize the probability of a bad outcome occurring. I just think that in practice, the research you'd want to do is pretty different between these two cases. You should also feel to jump in and answer any of the questions if you feel like it.
Yeah, I would say there's potentially a bunch of overlap as people are more worried about. I think it depends on where the most easy point to intervene on misuse is. So for misuse, often you're well, if we can detect jailbreaks, that would also work. So to the extent that people are well, the way that we're going to handle prompt injection, we're let's just talk about prompt injection, just at least analogous. There's sort of misuse. If you're thinking about prompt injections for agent scaffolds, one measure you could use is assume all of our models were prompt injected unless we carefully held them out, and then that will be a somewhat analogous problem with some transfer. But there's also a very natural approach, which is detect whether or not it is a prompt injection, and it's very likely that that's a better approach because handling it afterward is kind of a crazy approach in some ways, whereas in this case we don't really have a choice. I think that for bio misuse, I think the problem is going to look very different in practice because you're dealing with a regime where you're we have some input from the user where we think the input might be jailbroken, and we get one response, and we're is this response bad? Whereas often we're dealing with regimes that just I don't know, look somewhat different in various ways. I think there'll be some transfer depending on the technique, and in fact, that's one of the reasons why you might be more optimistic about this direction is that to the extent people are already dealing with misuse, maybe we just need to insert the right 10 tweaks and additional things to do, and then we get it some of the way there. So some of it, I don't know.
Another one is Anthropic, for example, mostly thinks about risk from outside people rather than risk from insiders. And the fact that this is an insider risk situation, like the threat model that I actually have here is you're an AI company and you're using your AIs to do huge amounts of work inside the AI company who have and these AIs have access to all kinds of resources that like randos off the street don't have, like your model weights and like your cluster and the GitHub, which is your like mono repo where all your code lives. And I think this just like causes a bunch of very big structural differences. Yeah.
So it seems like there's a abstraction race that's going on here, right? Where you have these two adversaries, and if your one model is, highly conceptual, it can encapsulate the strategy of the other model, and that there's the outcome of this from this is like two kind of preliminary conclusions. One was like use decentralization and break the machine into multiple pieces because it's harder to coordinate across those different layers. And then have you guys thought about adding noise from like mixed strategy equilibrium where there's some RAN that goes through where the evil machine trying to collaborate with the other evil machine ends up inevitably revealing itself by thinking that the human pretending to be evil, like that kind of thing.
I'm gonna go with like yes. There's a bunch of things like that you can try.
Yeah, I think like mixed strategies sometimes look good for the blue team, but we just didn't consider any in this paper for simplicity.
I've got time for like a couple more. Yeah.
Yeah, I was wondering about more relaxations, like if you change the situation to have like you allow for like 2 failures or something like this.
Mm-hmm.
How much easier it gets?
A little bit. Yep.
So it's not like a massive reduction.
I mean, I think your safety numbers are going to get like square rooted or something,
Yeah.
like roughly. Like I can imagine in a lot of places, like safety is going to go from like 60% to 80%. One way you can basically model this for a lot of these is like every time the AI attacks, 3 things can happen. It wins, it loses, or the game continues, right? And so in this setting here, if you think the attack rate is high enough that it's, so like the way the game can end is either the AI wins, the AI loses, or we get to the end of the game and no one has won or lost, in which case the AI loses from a safety perspective. And so if we know the probability that on a given attack, the AI wins versus the AI loses, if we want to talk about the probability that the AI wins twice before the AI loses, then we just like naively, you just like take the probability the AI wins in a given thing and square it and compare that to the lose probability.
Yeah, just another question. I do a lot of like backdoor defenses and in general. And I feel, do you think this is like, do you consider this like the main defense you want for alignment, or do you consider this like one extra step? Like you might also be doing like some mechanistic interpretability stuff. You might also be like just monitoring the inputs and outputs separately, like. And this is like just an extra thing to see if you're not sure of those other steps, and you just view this as like, yeah, you should mainly be doing this.
It depends on depends on how broadly you mean this. I think that reasoning through your risks by considering your AIs to be sources of insider threats is like the main line of defense against the AIs in fact being insider threats.
So it just seems like you should just be doing this regardless of like if you have decent techniques to do detection, like just in case like your other types of techniques aren't like guaranteed to give you.
Yeah. So what you're saying is like if you aren't sure that your AIs aren't insider threats, then you should treat them as if
you have like you're not like complete. You don't completely. It's not like a complete unknown. Right?
Yeah.
Like you have some information. I guess is what I'm saying.
But the thing I would say is
great.
Go outside.